Assalamu alaikum students. Lastly, we have read about the refraction of light, and now we people are aware refraction is simply defined as the process, the phenomena in which a ray of light, when it goes from one medium to another medium at interface, only at interface it bends. It changed the direction. The actual direction was this, but changed the direction, moved like this in this very medium, in denser medium as it is, or here in case it is the rarer medium. That is, it got deviated from its original track, and then that very angle is called as the angle of deviation. We found when a ray of light goes from rarer to denser medium, optically rarer to optically denser. What is optically rarer? A medium in which the speed of light is very large, and the medium in which the speed of light is smaller as compared to this medium, that's called as optically denser. Interface is a, you can say, a boundary between the two media. It can be two, water and glass, or something, diamond and glass and water. It can be anything. So now, after having the concept of refraction, so if angle I is greater than angle R, then refraction, then ray of light goes from rarer to denser. If angle I is less than angle R, then ray of light goes from denser to rarer. Now after this, we have to read about what? laws of laws of refraction. You might have read these very laws in your previous class, 10th class, but we have to repeat them out here. What are laws of refraction? The first law is like this: the incident ray, law number first, that is the incident ray, comma, refracted ray, and normal at the point of incidence all lie in a single plane. So what I'm saying, plane. So this is the incident ray, this is the refracted ray, and this is normal. They all are in a single plane. That is, they do not deviate their path. If this is a plane, the plane here is the notebook. So all the rays, the incident ray, the refracted ray, and normal, all are in single plane. The normal is not inwards and upwards, or neither the refracted rays upwards or downwards. Those all are in this very plane. So this is the first law, that is the incident ray, the refracted ray, and the normal all lie in a single plane. Now there is the second law, which is important one, which is called as Snell's law. Second law, which is also called as Snell's law. What is that? That is the ratio of the ratio of sine of angle of incidence to the sine of angle of refraction for a pair of media is always constant. Which you have to understand. What does this law mean actually? This law actually means, for to understand this very law, let's have a media here, two media actually. This is the boundary separating the two media. This is the ray of light which is incidented here, and this is the normal. Then this very is called angle of incidence. This is called angle of refraction. Now what actually it is, that is Snell's law, is sine I by sine R is constant for a pair of media. Listen what actually it is. It means, if we are having two media, let it be water, H2O is the water, and this is glass. Now this angle of incidence is something, let it be 30 or 40, then we will be having a R for it. Let it be 30, we will be having R for it. Let it be 60, we will be having a different R for it. In the same media, also, same media, the ray is going from rarer to denser medium. I is changing, R is changing, media is not changing, medium, both the medias are same, water and glass. Ray of light is going from water to glass. And in every time, I am going to see sine I by sine R. First, sine 30 by sine 40, sine 70 by sine 40 or something else. So once I will calculate the ratio for all those very sign, I will change the eye. There will be a totally different eye. Let me place one another ray. It is now a totally different eye. Actual pass is like this, but it will deviate. It will go like this. It will go like this. So there will be some. If it was I1, it will be R1. If it was I2, it will be then R2. So on. But if I will take sine of I1 over sine of R1 should be equal to sine of I2 over sine of R2 should be also the same constant. That is, for a pair of media, the constant should not change. And this very constant gives what? Refractive index of the medium. Refractive index of medium. Refractive index medium actually tells us how much the ray of light has got bended, how much it has got bended once it go from one medium to another medium. So simply Snell's law. What is Snell's sometimes it's asked? Snell's law is defined as the ratio of sine of angle of incidence to the sine of angle of refraction for a pair of media is always constant. That is, if you are going to change I, you will be having definitely different R's. And if you will take always sine I by sine R, sine I by sine R, sine I1 by R1, sine I2 by R2, sine I3 by R, you always get a constant number for a pair of media, and that is called as what? That is known as Snell's law, which is very much important. So this very constant gives us actually a refractive index of medium, this very medium. That's how much the ray of light has got bent from its origin path. That's called as the refractive index. In detail, we will read about refractive index tomorrow. Till then, Allah Hafiz.